Welcome, data enthusiasts and knowledge seekers. Today, we embark on an awe inspiring journey into the heart of a cutting edge discipline that flows the very essence of our digital age. So, first of all, I would like to ask you, have you ever wondered how Netflix recommends new shows to you or how self driving cars work? Well, my friends, the answer lies in the captivating world of data science. Let's start by defining the data science. So, the data science is the study of data to extract meaningful insights for business. It is a multidisciplinary approach that combines principles and practices from the fields of mathematics, statistics, artificial intelligence, and computer engineering to analyze large amounts of data. This analysis help data scientists to ask and answer questions like what happened, why it happened, what will happen, and what can be done with the results. Then let's discover why is data science important. Data science is important for several reasons. First of all, we have data-driven decision making. Data science allows organizations to make more informed, data-driven decisions by analyzing large volumes of data. Data scientists can identify patterns and insights that can inform decision making across a range of files. And then we have the business value. Data science can help businesses to reduce costs, increase revenue, and gain a competitive edge. By using data to inform business decisions, organizations can optimize their operations and drive growth. Then we have innovation. Data science is a key driver of innovation in many fields. For example, in healthcare, data science is being used to develop new treatments and improve patient outcomes, while in finance, data science is helping to detect fraud and manage risk. We have also personalization. Data science is also important for personalization. By analyzing data about individual preferences and behavior, organizations can provide personalized recommendations and experiences to customers. Then we have at least future planning. Data science can help organizations to plan for the future. By analyzing historical data and trends, data scientists can make predictions and forecasts that can inform planning and strategy. Then let's discover together what is data science used for. Data science is used to study data in four main ways. First, we have the descriptive analysis. Descriptive analysis investigates data to learn more about what happened or what is happening in the data environment. Data visualizations such as P charts, bar charts, line graphs, tables, or created narratives are its defining characteristics. Then we have the diagnostic analysis. The diagnostic analysis is a deep dive or detailed data examination to understand why something happened. It is characterized by techniques such as drill down, data discovery, data mining, and correlations. A given data collection may be subjected to a variety of data operations and transformations in order to find specific patterns in each of these methods. Then we have the predictive analysis. The predictive analysis uses historical data to make accurate forecasts about data patterns that may occur in the future. It is characterized by techniques such as machine learning, forecasting, pattern matching, and predictive modeling. In each of these techniques, computers are trained to reverse engineer causally connections in the data. Then, at least, we have the prescriptive analysis. Predictive analytics advances the use of predictive data. It not only predicts what is likely to happen, but also suggests an optimum response to the outcome. It can assess the probable effects of various decisions and suggest the best course of action. It uses graph analysis, simulation, complex event processing, neural networks, and recommendation engines from machine learning. Now, what is the data science process? The process of data science is the OSEMN process that provides a systematic and iterative approach to solving business problems using data, and it is a valuable tool for data scientists to ensure that their work is aligned with the business objectives and requirements. So let's start with the first one, which is O. Obtain data. In this step, the data scientist collects or obtain the data needed from relevant sources to solve the business problem. Then we have the S, which is scrub data. In this step, the data scientist cleans, transforms, and preprocesses the data to make it suitable for analysis. Then we have the E, which is explore data. In this step, the data scientist explores the data using statistical techniques, visualization tools, and other methods to gain insights and identify patterns. Then we have the M, which refers to model data. In this step, the data scientists build and trains a predictive model using the data and tests its accuracy and reliability. At least we have the N, which refers to interrupt results. In this step, the data scientist interprets the results of the model and communicates them to the business stakeholders, providing recommendations and insights based on the data analysis. So let's see what are different data science technologies. Data science practitioners work with complex technologies such as artificial intelligence, leverage machine learning models, and associated software to conduct predictive and prescriptive analysis. Then we have the cloud computer. The advent of cloud technologies has provided data scientists with the necessary flexibility and processing capabilities to conduct advanced data analytics. Then we have the Internet of Things. IoT encompasses a variety of internet connected devices that collect data for data science projects, generating vast datasets suitable for data mining and extraction. Then we have the quantum computing. Quantum computers enable data scientists to develop intricate quantitative algorithms thanks to their ability to perform complex calculations at incredibly high speeds.